Hello friends, welcome to another lecture of vector calculus. So this is lecture 3 of mathematical physics vector calculus. So this is for M.Sc and B.Sc students, and topic we're going to discuss here, vector product, or you can say cross product. And link of the previous lecture, lecture 2, is given in the description box. Please watch that first for better understanding. So before we start, let me tell you, please subscribe the channel if you are new to my channel, and if you think it's helpful, then do share with your friends and hit the thumbs up button, and help me to grow my channel and inspire me to create new contents for you. So let's start. Now vector product of two vectors, suppose vector A and vector B, is given by vector A cross vector B is equal to magnitude of vector A and magnitude of vector B sine theta and cap. Suppose this is your vector here, you see, let me tell you, suppose this is your vector A, this is your vector A, this is your vector B, and if you curl vector A to vector B, then you're gonna get the cross product, and the resultant vector of that cross product will be perpendicular to both A and B, right? If angle between A and B is suppose theta, then A cross B, the resultant vector will be A cross B, will be perpendicular to both A and B, and this n cap is the unit vector along that resultant vector that you get from A cross B, right? So here n cap is the unit vector perpendicular to both vector A and vector B. So now you see, direction of n cap can be determined by right hand thumb rule, okay, by the right hand thumb rule. So if you curl your fingers, if we curl our fingers of right hand from vector A to vector B, then the thumb will give the direction of n cap, which is the unit vector along the resultant vector of A cross B, right? So here you see, remember one thing, in A cross B, when you find a cross product, A cross B is not equal to B cross A, remember that, okay? You can say that A cross B is equal to minus B cross A, right? So now let us discuss its geometrical meaning. So here the resultant is also a vector, okay? So geometrical meaning of cross product or vector product of two vectors, suppose these are the two vectors A and B. So here you see, let me consider that these two vectors are adjacent side of this parallelogram. So this is theta, between the angle between the two vectors, and this is the perpendicular I have drawn here, and O, A, B, C. So we have considered vector A and vector B are the adjacent side of this parallelogram, and this point is suppose D, right? And the direction of the resultant vector will be along this green color line you can see here. This is n cap, right? So let us consider or assume that a vector A and vector B, the two adjacent sides of a parallelogram, that is OABC, such that A and B are two sides of OA, two sides O and OC, right? So vector A and vector B are represented by the two sides OA and OC of the parallelogram respectively, and CD is perpendicular to OA, angle COA, angle COA, this angle is theta, right? Then here you see, from triangle COA, from this triangle COA, so let me consider this triangle. You can see this triangle, this is COA, right? From this triangle, what you can write? Sine theta. Sine theta will be equal to what? We know sine theta. So if it is your right angle triangle, this is your theta, suppose this is your theta, then this one will be perpendicular, this one base, this is hypotenuse, and sine theta is what? perpendicular by hypotenuse. So here the hypotenuse is is represented by CU or OC, and the perpendicular is CD, right? So here you will get that CD by sin theta is equal to CD perpendicular by hypotenuse OC, right? So here you see, let me clean this part. Okay, CD is equal to, this implies CD is equal to OC sin theta, right? OC sin theta. This is suppose equation number 1, right? OC sin theta. Now you see, A cross B is equal to magnitude of vector A, magnitude of vector B, sin theta n cap. N cap is the unit vector along the resultant of A cross B, right, which is perpendicular to both A and B vector, right? So vector A, magnitude of vector A represented by side OA, and magnitude of vector B is represented by OC side, right? So OA into OC sin theta n cap, right? Now OC sin theta is the perpendicular CD, right? And OA into CD, you can write that way, n cap. So this is OA into CD is nothing but area of the parallelogram, right? Parallelogram, because you see, this is OA is the base of this parallelogram, and this is the height of this parallelogram, and CD is the height of the parallelogram. We know area of a parallelogram is base into height. So hope you have got this parallelogram OABC. So this is the geometrical meaning of this A cross B, right? So magnitude of A cross B gives the parallelogram whose adjacent sides are the magnitude of the vectors A and B, right? So hope you have got this. This is base, this is height, right? OA, base, CD, height. So that's why n cap is the direction of the area vector, right? So now if vector A is ax I cap, ay j cap, az k cap, and vector B is this bx I cap, by j cap, bz k cap. So we can find A cross B using determinants also, right? So I hope you know how to evaluate determinants. So let me show you here. So first, let me tell you some important results. Okay, so this is the coordinate system, suppose x, y, z, and unit vector along x-axis is I cap, and that along y-axis is j cap, and unit vector along z-axis is k cap. Now if you find I cross I, right, I cross I, angle between I and I, that will be definitely 0. Then I cross I, and magnitude of unit vector is 1 into sine 0 degree, that's sine 0 is 0, so it's going to be 0. So similarly j cap cross j cap will be 0, k cap cross k cap will be also 0. And similarly if you find that I cap cross j cap, that's going to be 1 into 1 cos 90, so that's going to be 1 cos 90 k cap, direction will be k cap. So I cap j cap, if you take your right hand, if you curl your fingers from I to j, then thumb will be pointed towards the z vector, that is its unit vector is k cap, so you will get here k cap. Similarly j k will give I, and k cross I will give j k. So hope you have understood this. So now let's find the determinants, right? A cross B will be given by ax bz minus by az I cap, right? So what we have got to find I cap, what we have done, we have multiplied this one, then minus we have multiplied these two, right? We have multiplied ay bz, then by az, their difference into I cap. So hope you know this. Then let me clean this. Then we have to use here minus. If this is plus, then minus, then next one will be again plus. Okay, remember that. Then j cap, in order to find the j cap, what we need to do, we have to multiply ax bz, then bx az. So hope you know this. So just if you don't know, just concentrate. Okay, so I'm not gonna explain again the same thing, because you must have got in HS level, senior secondary level, this how to determine how to evaluate determinants. That's very simple, right? So we have got ax bz minus az bx z cap. So what we have done here, let me tell you again. See, to find z cap, ignore its corresponding column, then multiply this 2 minus, then multiply this 2. To find k cap, ignore its corresponding column, then multiply this one with by and bx with ay, right? That's the way you find right now. Okay, here you see minus plus this time, then ax by ay bz k cap. So k cap into, so here you see, now we are taking k cap here now, so ignore this, then multiply this 2, then minus, multiply this 2, right? Similarly, in other cases where when we had taken here z cap, then what we did here, let me tell you again. So just concentrate, okay, for better understanding. When we have taken here z, then we have ignored this column, then ax bz minus bx az. So same thing is done here also. So hope you have understood this. That's how we can use determinants to find vector products of two vectors. So hope you get it. So now let me show you some problems. Let us solve some problems. Okay, so here you see first question: what is the unit vector of the vectors, unit vector perpendicular to the vectors or plane perpendicular to the plane containing the vector a and b, if the vector a is this one. So let me write the vector a and vector b is this, right? So now let us solve it. So let me write the given vectors first. These are the given vectors. So we know when you find a cross product of two vectors, the resultant vector is perpendicular to both. We know that. So let's find a cross product first. Using determinants you can find. So as I have already explained, that first to when you take I cap into then ignore this, then multiply 3 into 2, then minus 1 into plus 1, right? 3 into 2 minus 1 minus, then minus 1 into plus 1, that's going to be minus, so 6 plus 1, right? You're going to get this, right? So similarly we can find z cap into so first let me tell you. So we have taken this to 3 to the 6, then minus 1 into 1, that's minus 1, so 6 minus 1 into I cap, right? So let me clean this. Then when we have taken z, here we have to take minus here, then 4 to the 8, then 8 2 1 the 2 into z cap, right? Then again positive, then let us take k cap, then here you see what we have done, 4 into minus 1, right? So let me repeat it. You can see 4 into minus 1, that is minus 4, right? Then minus 2 3 is 6, then k cap, right? So that's how we need to do. So in next problems I'm not going to explain this how to determine the how to evaluate these determinants. So if you haven't understand, just remind the video and watch it again. Okay, so now if you evaluate this, then you're gonna get this. So this is your resultant vector of a cross b. Now unit vector perpendicular to both a and b, or plane containing a and b, will be given by this vector, resultant vector, divided by its magnitude, right? So if you find that this is magnitude of this vector, right? If you find that, then you're gonna have this result. Okay, so this is your answer. Now next problem is find the sign of angle between these two vectors, sign of angle between these two vectors, right? let me write the given vectors here. This is vector A, vector B. Okay, so let theta be the angle between these two vectors. So we know that A cross B gives AB sine theta n cap, right? So n cap gives the direction. If we take the magnitude only, this AB sine theta, then you will magnitude of A cross B, that's going to give you AB sine theta only, right? And from here we can find sine theta is equal to, that is sine of angle theta, which is between the A and B vector. So here magnitude of A cross B divided by magnitude of A and magnitude of B, that means A into B, right? So let's find the A cross B first. If you use determinants to find A cross B, here I'm not going to explain how to evaluate determinants again, so hope you have understood that. So this is going to be the result. Here you can see this is the result. So now find its magnitude. Magnitude will be this. So here is the magnitude of that vector product, and right. So now let's find the magnitude of vector A. That's gonna give you here root over 6, I think, yes, root over 6. And that of vector B, magnitude of vector B will be root over this one, and it's gonna be 26, right? Now let us put these values here, magnitude of A cross B and magnitude of A and B, right? And putting those values here, what we have got, sine theta is equal to, so what we have put here, this one is placed here and these two values are used here. So then what we have got, this. So this is your answer, right? This is your answer. So hope you have understood this. Now let's move on to next problem. Okay, so question number 3, find the angle between vector A and vector B if A cross B, vector magnitude of A cross B is equal to A dot B, right? So here given that magnitude of vector A cross vector B will be is A dot B, right? We know A dot B is a scalar, right? The dot product of two vector is scalar and cross product is vector, so we are taking here, so it is taking only magnitude, right? So if theta be the angle between them, then cross product will be given by AB sine theta, right? And in this is the magnitude only, and dot product is given by AB cos theta. Now AB gone, so sine theta by cos theta, that's going to be equal to 1, and sine theta by cos theta is tan theta, so 1 tan 45 is 1, so theta will be 45. This is the angle between these two vectors A and B. So hope you have understood. Now next problem is find area formed by the points whose position vectors are this. These are the position vectors of 3 points, 3 vertices of a triangle. Okay, so now here suppose we have taken, these are the position vectors of the 3 vertices. We have considered the vertices, suppose ABC, position vectors of ABC of triangle ABC. Okay, we are to find area of triangle ABC. Now this is the coordinate system x, y, z, and here is the triangle. Suppose this is A, B, C, right? These are the 3 points and their position vectors are this. These are the position vectors relative to the origin, relative to this origin. Oh, this is the origin, oh, right? So now let's find the AB vector first. This vector AB vector will be given by B is the terminal point, A is the initial point. So position vector of terminal point minus position vector of initial point, right? So that's how you will get the vector AB, right? So position vector of the terminal point, that is B here, is given we have considered this one as position vector of B, right? So this one position vector of terminal point, right? So hope you have understood this. And this is the position vector of initial point. Initial point is here A, right? Starting point is A here. Similarly, let's find AC, this AC vector, this vector AC, right? So this is, I have written here BC, so I made a mistake here. So this should be AC, right? This should be AC. So AC here, terminal point is C, and its position vector is this one, right? and initial point is A again, so this is the position vector, 3i plus j, right? So same procedure, final position vector of the terminal point minus position vector of the starting point or initial point. So then you're gonna get these two vectors after subtracting, right? These are the two vectors which represents the adjacent sides of a triangle ABC, and you can here you see, if you find a cross b, right, a cross b, and its magnitude will give you the area of this parallelogram. You can see this if you consider these two vectors AB and AC vectors as the adjacent side of this parallelogram. You can see adjacent side of this parallelogram. Then cross product of these two vectors, magnitude of the cross product of these two vectors gonna give you the area of this parallelogram, right? So to get the area of this triangle only, you have to take half, because diagonal of a parallelogram divides it into two triangles of equal areas. So then let us take magnitude of this, and if you take half, then you're gonna get the area of this triangle ABC. So hope you have understood why we are taking half here, because magnitude of A cross these two vectors AB cross BC will give you the area of this parallelogram, right? This whole parallelogram, and if you take half, then you will get the area of this triangle, right? So that's what we are going to use, this concept we are going to use here. So now let's find AB cross BC, right? So using determinants, if you find it, what you're gonna do, right? So here you see, from vector AB we have got 2 1 1, then vector AC we have got -2 -3, then 3. So let's find a vector, resultant vector here. So what we have got here, so this is going to give you this vector. This is the AB cross BC, right? So let's take its magnitude, right? So area of triangle ABC will is equal to half of magnitude of AB cross AC, right? So again I have written here BC, so that should be AC actually. So I made a mistake here. That should be actually AC, right? AC vector. So we are taking these two vectors now, AB vector and AC vector, right? So here don't be confused, this is AC, right? So AC vector. So magnitude of this AB cross AC is given by root over 6 square, and let me take half here, this half is taken here, right? 6 square minus 8 whole square, then minus 4 whole square. So square of this one, square of this one, square of this one, right? So hope you have understood this. So then what you will get, so if you calculate this, then you will get half of root over 116, and 116 can be written as root 4 into 29. Square root of 4 is 2, so root 2 root 29, and if you take the half of 2 root 29, 2 will be cancelled, then you will get the area 29. So this is your answer. So hope you have understood. So if you think this video is helpful, please do share with your friends, and if you like my video, and hit the thumbs up button. So stay connected, and if you are new, then subscribe the channel. Also press the bell icon so you get notified when new video will be uploaded. So when you do comments and you do like videos, then you make us inspire, so to create new contents for you. So thank you for watching. See you in the next video.